Welcome back, everybody. Now I'm going to show you how to do these three hypothesis tests using the p-value method, which makes use of our calculator. And of course, the p-value enables us to make a decision regarding our hypotheses. And of course, our decision with the p-value method corroborates with our decision with the critical value method, which was shown in earlier videos showing all 5 steps. The first one, of course, is going to be the two-tailed test. I'll take them in the same order that I demonstrated them in with the critical value method. The two-tailed test involved a study of 420,095 Danish cell phone users, 135 of which developed cancer of the brain and nervous system based on data from the Journal National Cancer Institute as reported in USA Today. We were to test the claim of a once popular belief that such cancers are affected by cell phone use. We are to test the claim that all cell phone users develop cancer of the brain and nervous system at a rate that is different from the rate of 0.0340%. Of course, when we conducted this test the critical value method way by showing all 5 steps, we were not able to reject the null hypothesis, and so the claim was not being supported by sample evidence. Let's see if indeed that is the case when we do this problem using the p-value method. And of course, we would expect our p-value to be very large, which would force us not to be able to reject the null hypothesis. Okay, so to conduct this two-tailed test, we hit our stat button. We go over to tests. Whoops. Then we go down to the one prop Z test. That's short for one proportion Z test. Okay. Dive into the one prop Z test. Now, P sub 0 is the purported population proportion under the null statement, which for this problem is 0.000340. X is the number of subjects that actually exhibited the trait of interest, which is 135 subjects. N is the sample size, which was 420,095. And of course, this is a two-tailed test, so we select not equal to for the alternative hypothesis statement. And then we can do to calculate. We're ready to conduct this one proportional Z test. There's our results. Of course, you can see this, this negative 0.6554. That's your test statistic. That's very close to what we computed when showing or doing the problem the critical value method. You can check back in your notes. And this is the p-value. The p-value is large, about 51%. And so because we have a large p-value, there's no way we can reject the null hypothesis, because if we did, we would stand about a 51% chance of committing a type 1 error, which is way too much risk for rejecting a null hypothesis, which in fact probably is true. So simply put, sample evidence is not supporting the claim that the proportion of all cell phone users that develop brain cancer or nervous system cancer is different than the 0.0340%. And so that's how you would conduct the test using the calculator. This is called the p-value method. Notice here's p hat, that is your sample proportion, which was about 3.21. That's what we all, well, 0.000321, as this is times 10 to the negative 4 power. This is scientific notation form. So to put this in decimal notation, you'd have to shift the decimal point 4 places to the left, which would turn us into a decimal of 0.000321, blah, blah, blah. Okay. All right, the next one we're going to do is the lower tail test, which involved the internet users. And the claim was that of the internet users, less than 50% used the internet for making travel plans. Of course, when we conducted this hypothesis test using the critical value method, showing all 5 steps, we were unable to reject the null hypothesis, and hence the claim that the population proportion is less than 50% was not being supported by sample evidence. So to do this test on our calculator, again, we hit our stat button. We go over to test. We go down to the one prop Z test function. Select enter. P sub 0 is the purported population proportion under the null statement, which is 0.50. X is the number of subjects in our sample that exhibited the characteristic or trait of interest, or characteristic of interest. That is those who did use the internet to make travel plans. That would be 360. And N is the sample size, the number of subjects that were randomly chosen from the populations. That would be 734. Of course, this is a lower tail test, so we select less than P sub 0. That's the same symbol used in our alternative hypothesis statement. Go down to calculate, and we're ready to do the test. So now we just hit enter, and the test has been conducted. Notice that the negative 0.5167 blah, 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 that's your test statistic. That's the same value that we computed approximately when we did the problem manually, showing all 5 steps. I think we computed negative 0.542, so it's a little off, but it's pretty darn close to this, and that really does not change our decision regarding this hypothesis anyways. P-value is large, about 30%. There's no way you would want to reject the null hypothesis with such a large p-value, as your probability of committing a type 1 error, of rejecting a null hypothesis that may in fact be true, would be way too large. And so therefore, yes, we are unable to reject the null hypothesis, and therefore the claim that the population proportion is less than 0.50 is not being supported by sample evidence. You can again see P hat is your sample proportion, which is 0.490, and that's what we computed when we did the problem manually. So this concludes a lower tail hypothesis test for a population proportion using the p-value method or the calculator. All right, one last one is the upper tail test, which was testing a claim that more than 50% of car crashes occur within 5 miles of home. And when we conducted this test manually, check back with your notes or the video that I posted, you'll see that we did reject the null hypothesis here, and so the claim was being supported. The claim being that the population proportion of accidents that occurred within 5 miles of home did exceed 50%. To conduct this hypothesis test, again, we hit our stat button, go over to test, go down and grab the one prop z test function. For p naught, we type in 0.50. The number of elements of our sample that exhibited a trait of interest was 5,720. Out of the sample size, which was randomly chosen from the parent population, which was 11,000. And this is an upper tail test, so we select greater than, and we're ready to do this test. Go down to calculate and hit enter, and boom, there you go. Notice our test statistic, about 4.195. That's what we computed when we did the test manually. And our p-value is 1.36, but it's not 1.36, ladies and gentlemen. Remember, a p-value is a probability, and probabilities cannot exceed 1. If you look further to the right, you'll see e negative 5. That means times 10 to the negative 5. This number is in scientific notation form. So to put this p-value into decimal notation form, you'd have to shift the decimal point 5 places to the left, which would make this number 0.000136, which is extremely small. And remember my saying, for p small, reject the null. And so therefore, since this p-value is extremely small, we would have no problem in rejecting the null hypothesis. In fact, this is an extremely conclusive test to reject the null hypothesis because your p-value is just so very small. And your chance of committing a type 1 error is so insignificant here that there's no risk whatsoever in rejecting the null hypothesis. So the bottom line, again, is sample evidence is supporting the claim that the proportion of all accidents that occur within 5 miles of home is indeed greater than 50%. That concludes this upper tail test for an unknown population proportion. So you can see that to conduct these hypothesis tests for population proportions, we always use the one prop z test when conducting the p-value method. on our calculator. Hope you enjoyed these videos, ladies and gentlemen. Please try to stay up with your homework and submit to me things that are due via email. Always keep your eye on the schedule, and that indicates to you what is due and when it's due. Um, and all should go well. Take care. Stay healthy.